Hi, welcome back to another video. So in this video we are going to look at the IKEV2 encryption type. So nowadays it's IKEV2 everyone is using. So now what's the benefit of this IKEV2? So IKEV2 gives you the very much flexibility, such as like if I say on the hub my encryption type is, what do we say, like AES CVC 128 and AES CVC 5112. I'm saying that any of these two encryption you can match, and I can say that group, I can say number 5, number 14, it's up. You can define multiple values over here, unlike the IKEV1. So in IKEV1, what you are doing is like you're defining a particular policy. In that policy you define only one value for encryption. In encryption, if you say 3DES, that's a one fix. You cannot add much more of that. No more values can be added over here. But here you can add more than one value. And now group, I said 5:14, and I can say that authentication pre-share, and I can also say that in the hash value. Now here we say that the hash value is equal to MD5 or SHA, but here we are going to say the integrity. It's the same thing, but the name is a little different. That's the only thing. So you can say that SHA maybe 256 and SHA 5112. So whenever you are using the IKEV2, you should be using the strong encryption. You cannot use the very weak encryption types, right? So this is the flexibility in the IKEV2. You can define more than one value. Now what happens is, like I'm defining for tunnel 1, I'm defining these values over on the hub. So I can define on the spoke saying that I want to do the encryption for AES CVC, and I want to match this only one value, and I can say that I want to match the group number 5, and I want to match the integrity as SHA-256. Now when it's try to form the tunnel, yes, it will form the tunnel. So that's the flexibility in the IKEV2, that if you define many more values, it will just match any of these values. So you can see that 128, it is having 128 gets matched. It is saying group 5, it is saying group 5, that is matched. And it is SHA-256 and SHA-256. The only thing is that you need to match the values with the multiple values. That's enough. Now coming with the IKEV2, most of the time you do not create the policies, unlike the IKEV1. So you say that policy, then you will define that address key and all those things over there. But here by default, so you can use that one. By default there will be one proposal, and by default there will be one policy created for you. So even if you do not define these values, still it will form a tunnel. So you no need to define those values over here. By default it is being defined, and you just need to configure the phase 2. That is, you have to just configure the key. You just have to configure the crypto IPsec, and you have to configure the IPsec profile, and you call that profile into the tunnel interface tunnel. That's it. That's the only thing you have to do in the part 2. So you need not worry about the part 1, because by default it will be available for you. So let's see where we can see that values over there. So I'm on the hub now. So if I say that show crypto IKEV2 proposal, and you can see that proposal. The encryption type is AEC CVC 256, 192 and 128. These are the 3 encryption types now supported. So if you cannot say that 3DES and all those things, DES and 3DES, that has been depreciated on the IKEV2 now. Only these are the values which will be supported. And similarly with the hash values, SHA-512, 384, 256, 96 and MD5 96. You cannot say that MD5 only, that has been depreciated. Now you can see that it says DEFLHAM group, it's number 5 and number 2. That's the 2 values over here, and it will also include the 14. I think it's included in this one, default one. So by default it is being defined. So if I say that show crypto IKEV2 policy, and you can see that by default the policy has been defined. So for the tunnel number 1, you need not worry anything. The only thing we have to provide is the key. So it should be matched, the key should be matching. So once the key is matched, it will form a tunnel number 1. Then it will look for the part 2 and it will do the integration for the data traffic. Right. So now before we go ahead, I will show versions. I will show that what kind of version I am using. So I am using version 15.73 M2. This is the version I am using for my Cisco IAU routers. Right. So let's go ahead and configure that one. So I'll bring up my notepad. Now, first I will define like crypto IKE version 2 keyring. I will give it a name, anything, and you can say that pre-check. Let me check the command. So config t crypto IKE version 2 keyring kr, and it says that peer. I will say all. It can since I am doing DMVPN, so I am forming tunnel dynamically. So I will just give it a name, tier all. So if you want to form a point-to-point tunnel, then you have to give a particular host name or something, but you can give any name. And after that, it will say that address. You have to give the address after that. So basically, once you say that my peer is hub 1, then you have to give what is the address for the hub 1. But we are doing DMVPN here, so you have to be careful here. I'm just defining a name. It can be anything. It doesn't need to be like hub 1, hub 2. It can be anything. Now next is that what kind of what is the address for that particular peer. So for now I am forming DMVPN. It should be anyone. It can be anyone. So what I will do, I will say that 0.0.0 and 0.0.0. Now key, preset key. I have to define the preset key. So once I have defined my address that it can form a tunnel with anyone, I have to define my preset key. So I will define my preset key as remote and local. It can be anything. So basically, what do you mean by remote and local is that at one side I can say that preset key is Cisco. At another side I can say that preset key is Cisco 123. Then what I have to do on R1 is that the remote is the Cisco 123 and the local is Cisco. That's how you have to define. But to keep that configuration simple, we use the Cisco as my key. So preset key will be Cisco. That's it. So what I mean by this preset key as Cisco, that means both remote and local are using the same keyword, Cisco. If I am using a different keyword over there, then I have to say that preset key remote. When I say remote, for example, I am forming with any other, I have to define that particular keyword what I am going to define. So this will be very useful when you are forming the point-to-point tunnel, but with respect to the DMVPN, it will become little problematic here because we are not even only forming one tunnel, we are forming multiple tunnels. So that's the reason that our encryption will fail. So that's it's better to keep only one keyword to avoid those problems. So once that has been done, no more. So if I say that do show run crypto IKE version 2 keyring kr, or I can say that do show run section crypto. And now you can see that this is the configuration which I have defined. So just copy paste on my here and exit and exit. That's it. I have defined a crypto keyring by name kr. I said a peer will be anyone, so I just gave it a name as all, and I defined the address. It can be anyone, but I am using the keyword as Cisco. Right now, next I will say that crypto IKE version 2 profile. Okay, let me check what kind of profile I have to create. Right, so I have to go with the profile. IKE version 2 profile, just give it a name as prof1. I'm giving any name. And now it is saying that a local and remote authentication method should be defined, and it should match an identity or like any match address or something. It should be like match statement should be there. I would say that match, you can see that these are the different things you can match. So now we are only matching the address. Match address any. So I will just say any, or says local That's it. So invalid 000. Let me check what I have to match. Match identity. So I will match the identity in order to what kind of it's a hub. I am giving an IP address, but what it is matching is when I do the address, it is matching the locally thing. So I want to match on the remote thing. So just have to define an identity instead of going with the address. So identity remote address. So this is the one you have to match compulsory on this one in the profile, and you can just define any address. Now I will set 000. That's it. Now authentication. You see that local appreciate key, and I'm saying that authentication remote appreciate. So locally and remotely I'm saying that you should use the appreciate key. What is the appreciate key? If you go up here, you see that appreciate key is Cisco. This is what we are going to use, but we have to say to my profile that where is that appreciate key located. So I have to say that keyring KR. So keyring local. That means I have created one keyring called KR in my local database, and just you have to match that key from this keyring and exit. That's it. If I say run show run section crypto, now this is the only configuration we have done. Just copy paste over here and exit. So now I created a profile, and I just defined matching the remote identity address, and I just said that I want to authenticate the remote address using the appreciate, and that appreciate key is being defined on KR that is located in my local database, and the key is Cisco. Next, that's the only first part, because we are not defining the proposal and policies by default. The default one, we are using the default ones. Now let's get the second part, that is crypto IPsec transform set. I will set a transform set tset ESP AES ESP SHA and HMAC and exit. Now crypto IPsec profile iProf. I'm just giving any name iProf. I'm just saying that set transform set to tset. And one more thing we have to set is set the IK version 2 profile, and that is prof1 and exit. Now interface tunnel 1 tunnel protection will be IPsec profile iProf1. That's it. Now I can copy and paste the same configuration on hub and spoke. Let's do a one more time review what we have to change if we want to copy and paste in other hub and spokes. So I said that a peer can be anyone, so there will be no change in hub and spokes, and the key will be Cisco. This is the key. Cisco will be matched on everywhere. And now I define on the match the identity remote address, and I said that 0.0.0. And remember, if you give an IP address, then you are only forming the tunnel with that public IP address of that particular host. So you have to be careful. So we are using the DMVPN, so definitely you have to use 00 because dynamically we are going to create the tunnel. Now authentication will be remote appreciate. That means remote will be having the same appreciate key that Cisco, and locally I am also authenticating with respect to that Cisco keyword. Right, and the transform set as we seen previously, so nothing to worry about it. And we just defined a profile. One extra thing in this profile is that we are just calling this profile. We are just calling this profile within an IPsec profile. So when we call in this one, these all values will be called up over there. So just go ahead and copy paste on my hub now. Okay, let me check what mistakes I have made. Okay, TRANS transform. Good, now encryption is up and running. Now one side my hub one is doing the encryption, the other side is not doing, so definitely our EIGRP neighborship will be down. I will just do the copy paste on my hub 2 first, and I will just copy paste. My encryption should be up and my neighborship should be up. I will do the same thing for my spokes now because my neighborship is down. Put paste. Encryption is up, my tunnels are up. My encryption should be up and tunnel should be up. Yep. And the last and the least, spokes. That's it. My tunnels are up. At this moment, everyone has the reachability to show IP IGRP neighborship, and I do have the neighborship with tunnel 1. So if I said I do ping 10.1.2.1 with source loopback 0, I am able to ping. If I say to show IP route, and you can see that NHRP has given me an override, and also I have given the NHRP static route. So if I said I do show crypto IKEV version 2 sub, and you can see that I have formed the tunnels. So now you can see that one tunnel is with respect to 0.2, one tunnel is with respect to 5.2, one tunnel is with respect to 2.2. So these are the 3 tunnels for now I have formed to exchange my key. And if I say that do show crypto IPsec sub, and this is where the encryption, you can see that I went for 1 to 2. This is my tunnel, and there is only one packet being encrypted for now. So what I will just do a ping one more time, and I will say that do show crypto IPsec, and it should increase. This value should increase for the same tunnel. So similarly, if I do the same thing for my another spoke, that is do ping 10.1.3.1 with source loopback 0, I'm able to ping. If I show that do show crypto IPsec sub, and I should be looking for a tunnel that is 3.2, so it should be on the top. Yep. So this is the tunnel, so this is only 1 now, so if I do one more time, it should increase the value. So similarly, what I will just do a ping with 10.1.4.1 with source loopback 0, I'm able to ping to show crypto IPsec sub, and the first tunnel is 4.2, and it is also encrypting and decrypting. So these are the verification of that one. If I say that do show IP NHRP brief, and I should see the tunnel building towards 2, 3 and 4. And by default the statics are hub 1 and hub 2. Now let's look with respect to our Wireshark. So this is my Wireshark on R1. So I'm just running the Wireshark on R1 E0/0, and now what I'm going to do is that from R1 I will just do a ping. So let's do ping 192.168, sorry, not 10.1.4.1 with source loopback 0, and you can see that ESP protocol is running. My encryption is being successful. So now I am encrypting the data packets. I will just stop it over here, and I will just try to drill down and see whether I can see my private IP address. So I can see my public IP address, that's definitely everyone can see it, but I'm looking for my private IP address. If I go to my encapsulation, that's where the whole packet is, that one. So within an ESP packet there will be my original header. So basically the first header will be the layer 2 header, and after that it will be the layer 3, that will be like a source IP address, that is my public IP address, and a destination public IP address. Then I have my ESP header, and inside that ESP header I do have my original header, that is my private source IP address and private destination IP address, source port and destination port, and then you have a payload. So this is the path. Now in between this one there is also a GRE, so this is where the GRE comes in. This will be the GRE header over here. Now if you see that the GRE header and the ESP, both of them will carry the same data, that is my public IP address. So what you can do is that when you are running the crypto IPsec transform set, so by default this will be the transform set will be running in the tunnel mode. Let me check whether it's a tunnel or transparent mode. So if I do show crypto IPsec sa, and now okay, this is my tunnel. Okay, inbound. Right, so you can see that my transform site is ESP-AES, ESP-SHA, NHMAC, and by default it is running the tunnel. So now in the tunnel mode, it's like you are having the duplication of the Gre header and the ESP. That means both of them are carrying the same data. So what you can do is that you can run your IPsec into the transport mode. So what you can do is like you can just inside this transform site, you can say that mode transport. So this will reduce around like 24 bytes of your data from the packet. Not exactly sure, but it will reduce the packet size. So that's all with the transport mode and the tunnel mode. But we are mostly interested in the encryption of the traffic. That is what we have verified over here, and we are verifying that it is been encrypting the traffic, and we are successfully building the Gre tunnel over here. So DMVPN is successful and we are encrypting the traffic here. So I hope this video was very informative for you. Thank you.